Good afternoon, everybody. My name is Grant Orchard. I'm the Field CTO here for HashiCorp, covering off our Asia Pacific and Japan region. And I want to talk to you about how we can make sure that the data that you're putting into Yugabyte Cloud can be kept safe and secure with our HashiCorp tooling. Now, before we get started, I love free things. I suspect there are some few of you who are listening today who might also like free things. If you can just scan this QR code and leave some feedback on today's session, you'll go into the draw for a $50 gift voucher. In addition, if any of the topics that we cover today during this session are of interest to you, please reach out to our sales teams. Our systems engineers would love to do some product deep dives with you around capabilities. And those same SEs also lead regular workshops where you can get hands on keyboard to try some of this stuff out firsthand. So please check out both of those links, scan that QR code, get yourself in the running for that voucher. So to set the scene today, I really just wanted to run through some of the themes that we're going to be looking at. So the first of all, it's really about that protecting your data. And when we look at how databases are consumed, there are really two main consumers, right? And it's going to be users, such as your database administrators, and it's going to be infrastructure and applications that are probably going to be running on one of those public clouds. And so the big questions that we often get when we're talking to customers, it's all about who can access my data. Once they've gained access to my data, what can they do with it? And how do we go about protecting my data from exfiltration, or at the very least, making sure that that data is completely unusable to anybody if it does get exfiltrated. So those themes are going to be what we're weaving through today. And again, we are going to be taking a look at the idea of users and systems/applications within that context. So before we get into it, let's talk about, first of all, what who actually means. And just wanted to sort of, mix things up a little bit here. We talk about identity as a first principle. It's something we understand pretty well as humans when we go to do things. Great example of that is trying to open a bank account or, interact with a financial institution or somebody else. When you walk into that building and you say, hey, I want to open a bank account, they don't just say, yeah, no worries, because they don't actually trust you. They don't know who you are. You need to prove your identity, and the way that you go about doing that is by handing over some kind of proof of identity documents. Here in Australia, we have what's called a 100-point identity system with more trusted, verifiable documents given higher ratings, things like passports and driver's licenses. Whereas as that proof of identity, maybe contains less information and is a bit less easy to verify, it kind of becomes secondary and can only contribute smaller points towards that identity system. So let's take a look at a driver's license. And there's some really interesting stuff here that goes on. Now you can see here that we've got my full name. We have a made-up address, a made-up date of birth here as well. Everything except my name is basically made up on this license. And the interesting thing here, of course, is like each of these, let's call it metadata, each component of that metadata is not necessarily unique, right? It becomes sort of the combination of these things that makes it unique. So how many Grant Andrew Orchards are there who live at 6 Somewhere Street in Richmond, New South Wales, who also have the date of birth of 20th of January 2000? Chances are there's none, right? It's only going to be one. Whereas if you just queried my address or my name or my date of birth, you're going to get multiple hits across the board. So it's the combination of unique things about me that we're sort of checking out here. Now, in addition, it's not just about me, but it's also about how do we verify the proof of identity itself? Like, is this driver's license a valid driver's license? And so when you go through the process of handing over an identity document to the bank, in this case, they'd reach out to the New South Wales government and say, hey, Grant has given us this card number, it's got this expiry date, it's got this information about him. Did you issue this particular driver's license to this particular individual? And it's the combination of the verification of the identity document as well as the that allows them to sort of verify and trust that the information about me that's being presented there is true. Right, so that's just the basis here. So I wanted to really get into that. Two key things: identity, the document, and also the verification. That's three things. But the verification is a pretty key part amongst all of this. So having laid that down, let's get into the idea of how identity then informs everything else that we want to talk about today. So if we look at the idea of accessing data, there are really sort of two main areas that we get into. Number one is the idea of network access, right? And which systems should be able to even communicate with my database. The second is, once we've sort of verified that, we present a set of credentials, which is typically authentication and authorization. We'll get to those components momentarily. To start with, let's look at that sort of first top image there. Now, within Yugabyte Cloud, they provide this concept of IP sets, right? So you can describe a set of IPs that are allowed to communicate with each of your database clusters that you're actually running. Now, that's great because what it allows you to do is, instead of just, exposing everything to the world, 0.0.0/0, hi, everybody, please come and have a look at my data. What you can do is, come down, and especially if you're making use of something like VPC peering, you can specify subnets or even, come down even finer grained within those to a set of IP ranges that should be able to connect to your database clusters. Now, part of the challenge that we have with using IPs here is that, this is all coming back to, the previous example that we spoke about, which is the idea of identity. Now, when we talk about IP addresses, there's no guarantee that, in those terms, it's actually Grant Orchard who's trying to connect to the database, right? Or it's my product service, it's my product API that's trying to communicate with my database. So we need to say, all right, how do we augment this capability of IP allow lists with something that's actually identity driven? So what I want to do is introduce you to how we tackle that problem, so sort of more broadly across the industry, right? And identity-driven access controls are pretty well understood for people, right? We've done this for a long time, where you can cryptographically prove who you are. You go to an application, it's going to redirect you to a third-party identity and access system, something like Okta or Google Workspace, Azure AD, Auth0, even GitHub, right? You can take advantage of that OAuth protocol and OIDC, which is sort of built on top of that, in order to present who you are, tap in some unique information such as a one-time password through maybe a hardware key or Google Authenticator or something like that, in order to prove your identity. And then based on things like group memberships, you will gain access to an application. What you may not be as familiar with is the fact that these same kind of mechanisms exist for systems or machines or applications, whatever you want to, I just could have broadly call those machines and group those together. So when machines are spun up for the first time, or compute instances are spun up for the first time, those could be like GitHub runners, GitHub actions, right? Using local runners, things like Cloudflare workers, which is not an image there, Kubernetes, Azure, GCP, AWS. All of these exist to allow you to prove the identity of machines. So they can present the identity documents across to an application. That application can then go off to the backend identity API and say, hey, were these documents provided to this machine that has this set of metadata? It really marries nicely with what we just sort of tackled with the driver's license scenario. Really powerful capability. Sort of at the top there on 12 o'clock of that identify and verify access, we have a picture of a certificate. Now, this is sort of, the lingua franca if you want to be able to communicate across services, because you're moving to something that can be verified outside of the platform. And this is the approach that we take with Consul, right? We take advantage of PKI, more traditional models of root of trust, in order to prove the identity of services. So let's take a look at how that ties into Yugabyte Cloud. So within this scenario, we've still got our IP sets there that are controlling, which IPs are allowed to communicate. On the left-hand side, we've just spun up a pod, right? And it's got the products API, and it is going to register to Consul and say, hey, here's my Kubernetes pod, here's who I am. In return, can I please get a certificate that's going to verify my authenticity? And so Consul provides that certificate. Now, when that pod wants to resolve and connect to the database, it's going to resolve that through Consul, and we are going to take advantage of something that's called a terminating gateway. Now, a terminating gateway is something that allows you to communicate with services that are outside of Kubernetes, which a lot of your persistent data is, going to be. And definitely in the case of Yugabyte Cloud, that's, running on a completely different platform. So the terminating gateway provides a couple of capabilities. First of all, it's going to be continually synchronizing, ACLs, what we call intentions within Consul, to say, okay, which services should be able to communicate with these target systems, right? In this case, our Yugabyte Cloud, can it be communicated to by our product service? Now, in this case, the answer is yes. So when that pod reaches out to the terminating gateway, it presents its certificate. The terminating gateway then says, oh, yep, okay, I've got a rule that says this thing can communicate based on the identity that's been presented to me. I'm now going to present back my identity document, which it can verify, and now we have mutual TLS between those. As a bonus add-on, since you're allowed to communicate, we then pass that traffic through, and our IP rules on the Yugabyte side are only going to need to be specified for the terminating gateways. So we've got much more control, much more restricted access in terms of just specifying those IPs. So those IP sets are in effect adding another layer of control by saying, hey, I'm going to say that I want the terminating gateway to handle the identity and verification, kind of in the same way as you'd say, yeah, we need the human teller at the bank to be communicating via a system to prove the identity that's on this license is actually valid. So really cool, great way to provide an additional layer of control around network access in terms of what you're doing with Yugabyte Cloud. So we kind of covered off that first one. I mentioned before that we're going to talk about authentication and authorization, and that is where we're up to now. Right, so this capability falls under Vault within our product portfolio. And since we've already covered off the idea of machine identity, I'm not going to go through that again. Suffice to say that Vault is able to also provide those same kind of identity mechanisms and I guess act as a trusted party that's going to go off and verify the identity that's provided. So our Kubernetes pod is going to say, hey, here is my Kubernetes service account or the JWT that's provided as part of that, and Vault is going to verify the identity again. In this particular case, our Kubernetes pod is saying, hey, I need a set of credentials in order to be able to connect to our target database system. So Vault is going to reach out and it's going to add a user, and it's also going to assign a grant to that user. So, I'm going to make a fool of myself here doing SQL queries online, but, create user with this randomized name with grant, read or write or whatever it might be to this particular table in the database, right? And once that process has been completed, those credentials are going to be sent back to the Kubernetes pod. Now, in addition, we're able to provide the idea of short time to live or easily rotatable credentials that is all handled programmatically. So you're really improving your model there in terms of what might happen in the event of someone accidentally logging credentials, those being discovered somehow, somebody writing them down, somebody, basically being able to get their hands on those and then try and take some kind of nefarious capability. If you can, move your credential rotation model down to, maybe every 24 hours, every week, every 30 days, whatever it might be, you're moving to a much more secure model than having static credentials that are very long-lived and really easy to discover and then exploit. So once those credentials are passed back, then they're used, right, in order to reach out to our database system. Now, the cool thing is, like, one of the great capabilities that this provides as well is you can now get much more granular in terms of the permissions and the scopes, right? So rather than maybe just having a product service that I've been talking about to date, maybe you have like a product read and a product write service, and you can now scope down the credentials that are actually being used and the permissions to then say, here are the things that you can do once you connect to the database. So that creates, again, that idea of how can we get more granular, how can we control the blast radius in the event that these credentials somehow get used get used for nefarious means, right? That's as simple as it gets, right? It's really, really powerful. It's really amazing, and it uses the same principles. So far, we've tackled the idea of machines being able to connect to, target systems, your target database. We've looked at Vault in terms of being able to handle and generate dynamic credentials, as well as the revocation of those after a time period. But the inevitable question is, all right, so we've looked at this from the context of machines and applications. What about people? Well, I'm very, very glad you asked. The people problem, we kind of discussed the idea of verifying identity from a human perspective and how that is a pretty well understood problem. And so we take advantage of the OIDC protocol with Boundary, so you can tap into your existing identity platform. You can create groups to entitle access. You can revoke those all within your central directory without needing to get in and manage and even distribute additional sets of credentials to your users and worry about that whole process. So Boundary, what is Boundary doing and how can it actually help you? Well, typically what Boundary is going to be doing is going out and discovering infrastructure that you are running, right, within each of the clouds or each of the target platforms. And then it is going to create a catalog of those services. For today's session, though, we're not talking broadly about infrastructure. We're talking very specifically about databases, right? And it doesn't matter whether you choose to deploy your Yugabyte service onto GCP or Azure or AWS, right? Those databases can all be ingested, or the databases themselves aren't ingested, but all of the details about how to connect to those databases can be ingested into Boundary and turned into a host catalog, right? As part of this process, we create targets within Boundary. Now, the example here is probably not the best one because I've just sort of said, hey, dev and prod, which are two unique targets. Now, targets become the intersection of the thing that you want to connect to and the credentials. So, maybe it would actually be better off saying, these are different project databases based on, the groups that you're within. Maybe it's that intersection of the projects that you're a member of as well as the target permissions that you have that are going to carve these things up. That'd be a better visual. Of course, credentials, as we spoke about, have already been covered relatively well. So Vault has the capability to dynamically generate credentials. So once a user comes in, they authenticate into your identity platform, they connect to Boundary. Based on the group memberships they're in, they see a certain set of targets. They also need credentials to be able to connect to those targets. So what we do with Boundary and Vault is allow Boundary to sort of proxy out to Vault based on that user. And depending on their permissions, again, they will get a set of credentials back, right? Vault will reach out to the target system, and what it's going to do is actually dynamically inject the credentials into the session. So the user never has them in the first place. So again, we're all about how do we reduce the risk profile. Once these credentials are injected to the session, they're then able to connect to the target, right? So whether that's the dev system, whether it's project A with role X, all of that is controlled basically within your identity and access system based on group memberships, which then are used to form the policies around Boundary. So really providing you with a really strong model in terms of who can access my systems, what are they able to do in terms of authentication and authorization, and then the revocation once the session ends. So once somebody says, all right, I've finished doing the work I'm trying to do within this target database system, disconnect, Boundary recognizes that, reaches out to Vault and says, okay, we need you to revoke those credentials now because they're no longer required. Really, really powerful, really transforming the way people are looking at secure database administration or just secure access and secure administration for these kinds of systems. With that, I'm going to get into data encryption, right? And this is the final discussion because it's all about like all the controls to date. With everything that you've done, what happens if somebody is still able to get in and exfiltrate my data? Maybe it's a compromised operator, right, who's been able to come in via Boundary and they've been able to say, hey, I've got access to read all the data, so I'm just gonna grab that. Data encryption is the way that we deal with that. So typically when we're looking at data encryption, it's all about sensitive information. So the example that I'm just going to roll with here is something like a credit card number. It can be anything that you like. Now, again, the machines are going to use their identity to authenticate to Vault in this case. And what we're going to do is send our clear text up to Vault. And what Vault is going to do is definitely not store that information. We do not store anything that we are encrypting when we start talking about this idea of transform, transit, format preserving encryption, etc. You send us the data, and in response, you get back ciphertext, right? So using the keys that have been specified on the Vault server, it's going to encrypt it, send you back the ciphertext, and you are then able to send that data across to your database. So you're getting field level encryption, which is a great capability. Now, why is this so powerful? If you think about what we were just talking about with regards to database access, whether we're talking about Boundary or not, you need to be on network in order to get access to the database system. Or maybe you don't. Maybe you've been able to perform a compromise from somewhere external. If you get the data back in an encrypted fashion, you need to perform a secondary compromise against Vault in order to be able to decrypt that data. Right? So what we're doing here is, again, laying in additional controls that make it much harder. Right? Now, and again, you'd have to stay on network in order to be trying to kick down the door of Vault in order to get those keys in order to decrypt that data. We don't allow you to export those keys from Vault. So it really is a really strong model in terms of providing a level of integrity around your data. Now, I can already hear people wanting to ask a question, right? If we think about databases, what do we know about their data? We know that they have a particular schema. We know that they expect to receive data in a particular format. Whether it's something like this credit card model or date of birth, there's a really specific schema that you need to provide data in. And if you just bring back ciphertext like this and you haven't sort of designed for it from the get-go, and we're talking about a brownfield application with a brownfield database schema, how do we go about managing that? Well, in fact, it's not too difficult at all. So within Vault, we provide a capability which is called format preserving encryption, right? And that takes advantage of the NIST AES FF3-1 algorithm in order to encrypt your data and return the ciphertext in a format that is consistent with the format in which it's received. So what this means then is if you aren't wanting to take the risk of making schema changes to your database, which is very, very understandable. Instead, what we're able to do is make a change to the way in which we encrypt that information to make sure that it is consistent with the schema that you're looking for. So with that, I know this was a very short session. I would have loved to have one of the team in here to provide a demo, but within half an hour, the time is quite strained. So look, we should have a few minutes left for questions here. I am on chat. Again, please, if any of this was interesting, reach out to us. We would love to talk with you. We would love to give you some opportunity to get hands-on with the technology and try this out yourself. Thank you very much, everyone, for your time today.